We take the moon for granted. It quietly controls our tides, lights up the night, and plays nice with Earth's orbit. But what if we swapped it out for something else? A planet, a star, a black hole? Today we're going to explore what happens when you replace the moon with something way more exciting, and maybe a bit terrifying. And yes, we're bringing real physics with us. Let's start with Mars. At first glance, it doesn't seem so bad. Rocky, red, familiar. But here's the twist. Mars is 10 times more massive than our moon. So if we placed it at the same distance, about 384,000 kilometers from Earth, things would get intense. Tidal forces, tides would become about 10 times higher than they are now. That means waves surging hundreds of feet in places. Coastal cities would be repeatedly flooded twice a day. And it's not just the water. Mars' extra mass shifts the Earth's Mars barycenter about 37,000 kilometers from Earth's center, making Earth wobble more noticeably on its axis. That wobble could lead to more seismic activity, potentially accelerating how fast Earth's rotation slows. What about the night sky? Mars would appear twice as large as the full moon. You'd see its reddish color, polar caps, maybe even surface markings, all with the naked eye. Night would glow with a reddish-orange light. Bottom line, it's dramatic. Coastal living becomes a bad idea, but Earth remains habitable, if a little soggy. Let's turn it up. What happens if we put Jupiter, the king of the planets, at moon distance? Here's the deal. Jupiter is 318 times more massive than Earth, and over 25,000 times more massive than the moon. Tides? Try 25,000 times stronger. The ocean would respond violently. We're talking kilometer-high megatides. Coastal regions would be scoured clean. The crust itself would crack under the strain, triggering massive earthquakes and volcanic eruptions. Radiation? Jupiter's powerful magnetosphere, around 20,000 times stronger than Earth, traps intense radiation. If we were that close, Earth would be deep inside its radiation belts, levels lethal to humans within hours without protection. The view? Absolutely stunning. Jupiter would stretch 20 degrees across the sky. That's 40 times wider than the full moon. You'd see swirling storms, colorful bands, and maybe even its moon darting around like bright stars. But all that beauty comes at a cost. Earth's surface would be uninhabitable. How about something a little gentler? Enter Pluto, just 0.2 times the moon's mass. Basically a cosmic snowball. Tides? They'd shrink to about 20% of current levels, so much calmer seas. Night sky? Pluto would look like a bright dot, about 2/3 the size of the moon. But thanks to the icy surface, it reflects sunlight well. You'd get a decent Pluto shine. And if you had binoculars, you might spot its moon Chiron slowly dancing around it every 6.4 days. But without our current moon, Earth's tilt would wobble over time. Seasons could shift more wildly over millennia. Climates might become less stable, and life as we know it would need to adapt. Final verdict? Peaceful, pretty, a quieter Earth, but one with a touch of long-term uncertainty. Let's bring in Titan, Saturn's largest moon. It's about 1.8 times the moon's mass, with a thick atmosphere full of nitrogen and methane, and lakes of liquid hydrocarbons. Tides? Roughly 1.8 times higher than today. Manageable, but enough to affect coastal infrastructure. The sky? Titan would look 1.5 times larger than the moon, a hazy orange disk. Its clouds would scatter light, making full Titan nights glow like early evening. It would also reflect 3 to 4 times more light than our moon, bathing Earth in a warm amber hue. It's a little weird, but we could adapt. Next up, Europa, Jupiter's smooth, icy moon. It's about 0.65 times the moon's mass, so tides would actually decrease, calmer seas. But its surface is basically a mirror. Europa has one of the highest reflectivities in the solar system, an albedo of 0.67. But what does that mean? Nights under full Europa would be 4 to 5 times brighter than a full moon. You might even see glints from ice cracks or water plumes erupting from its surface. It's dazzling and peaceful. We'd survive, and maybe get a closer look at its underground ocean. Let's get ridiculous. Put the sun where the moon is. 384,000 kilometers away. That's inside the sun's actual radius. Earth would now be floating inside a plasma furnace at 5800 Kelvin. No slow apocalypse, no time to panic, just psst. Earth vaporized in seconds. Atmosphere gone, oceans boiled, crust liquefied in under a minute. Earth is nothing but a wisp of ionized gas. There is no Earth anymore. Okay, how about a red dwarf, like Proxima Centauri? Smaller than the sun, cooler too, but at moon distance? Earth receives 470 times more energy than it does from the sun at 1 AU, which stands for astronomical unit. That's enough to boil oceans, destroy atmosphere, and turn the surface into lava. And don't forget the flares. Proxima regularly blasts out X-rays and ultraviolet radiation. Even if Earth isn't torn apart by gravity, it's slowly roasted and irradiated. Now things get weirder. A stellar black hole, say 10 times the mass of the sun, suddenly dropped at the moon's distance. It's invisible, but its gravity, absolutely unforgiving. The tidal forces would be thousands of times stronger than anything Earth has ever experienced. One side of the planet feels a significantly stronger pull than the other. Earth begins to distort, crack, and stretch. The technical term for this? Spaghettification. Mountains crumble, oceans lift off, the planet unravels. Within minutes, Earth is shredded into glowing fragments, spiraling into the black hole. They light up briefly and then vanish forever into darkness. No escape, no second chances, just a one-way trip to the void. Want something even worse? A supermassive black hole, like the one at the center of our galaxy. At that size, millions of solar masses, its event horizon stretches over 12 million kilometers. And the event horizon? That's the ultimate point of no return. The boundary where gravity is so intense, not even light can escape, cross it, and physics as we know it stops making sense. Now place that monster where the moon is, just 384,000 kilometers away, and guess what? Earth is already inside it. That means we're gone instantly. No light escapes, no signal, no warning. One moment Earth exists, the next it doesn't. Swallowed whole in cosmic silence. No explosion, just erased. Let's swap the moon with an Earth-like exoplanet, say Kepler 22b. It's about 9 times Earth's mass, and roughly 2.1 times Earth's radius. At that size and mass, the tides it would raise on Earth would be 730% stronger than what we get from the moon. We're talking tsunamis hitting coasts daily. The Earth Kepler 22b system would act more like a binary planet, orbiting a common center of mass every 8 or 9 days. Both planets would still orbit the sun as normal. The night sky would be dominated by a bluish orb nearly 4 degrees wide, 8 times the moon's size. You might see swirling clouds, maybe even glints from oceans. It's beautiful and deadly. The initial impact on civilization would be catastrophic, but maybe, just maybe, life could adapt. Let's finish with pure nightmare fuel. Wasp 12b, an ultra-hot gas giant, about 467 times Earth's mass, and so bloated by heat that it's basically bursting at the seams. It's so enormous, its atmosphere would overlap Earth's orbit, meaning if it replaced the moon, we wouldn't just be near it, we'd be inside it. Its dayside burns at around 2800 degrees Kelvin, hot enough to vaporize Earth's crust on contact. And the tidal forces, roughly 38,000 times stronger than what we get from the moon. Earth's oceans pulled skyward into space. The crust shredded and fractured. Tectonic plates don't shift, they disintegrate. And with all that gravitational drag, even Earth begins to spiral inward. Not over centuries, in a matter of hours, our planet is pulled into the furnace. A fiery plunge into a pitch-black gas giant that barely reflects any light. End result? Earth is gone, melted, swallowed, and erased. Just more mass added to the belly of a monster. So what did we learn? The moon might seem boring, but it's just right. Too small, and tides vanish. Too big, and they destroy continents. Too radioactive, and, well, you get the idea. The moon is quite literally perfectly balanced. Not too heavy, not too light. Just enough to steady our spin, stir our oceans, and light up the night. So next time you look up, give it a nod. It's the quiet hero of our planet's story. If If you like this video, don't forget to like, subscribe, and drop a comment with your next big what if. And as always, stay curious, because the universe is anything but ordinary.